All right, welcome everyone to this presentation about 3D visualization of multi-layer networking. I'm Maxime Millette Coulombe, software developer for Inocybe Technologies. So we're about 20 minutes over the schedule, so I will try to do it quickly, so we won't lose too many time for other presentations. So we'll start with the quick questions. So why should we start? Why should we visualize in 3D? Because for the network visualization, it's rare that we'll see it something displayed in 3D. Sometimes really, most of the time is 2D because 3D can be useless. So when we are talking to see if it's something that we need to do or not, it's kind of a question hard to answer, and sometimes some managing people can be afraid of doing this touch because it can, you need to have maybe a different expertise to be able to do it. So we'll just reduce a little bit this case because 3D visualization is very a global scope. So for networking data visualization, we'll try to answer another question which we kind of simpler. It's why just do some data visualization. So one of the reasons, again, there's a lot of answer to this question, but in this particular scope of this presentation, we'll say that we use visualization because we want to understand and correlate the most possible content of our data set, and we want to be able to show it in an easy way that everyone can be able to understand it. So if I can just show a little example, if you try to connect OpenDaylight to Mininet, you start a server with Mininet and try to connect it with OpenDaylight, you kind of be able to see something that you see at the picture on the right if you open it in Deluxe. So you will see that it's pretty easy to understand what's going on. You have 7 flows and see easily what are the links. So if there's an issue in your network and the open flow 5 doesn't mean to be connected to the one, you know it in about 2 seconds. If you need to look directly in the plain JSON, it's take way more longer. This, what you see in the left, is I've tried to trim the payload that the OpenDaylight give you, but this was way too big, so we just have a really small part of it. But if you just have this plain data, and we will try to figure out what your issue with your network. It would take maybe 5 to 10 minutes, and what you will do to be able to solve it, you will probably do a drawing similar to what you see in the topology. So doing visualization is really something natural that we are used to, and it's an easy way to do things. So of course, a picture talk more than just text. So now we can more have a bigger picture of why doing 3D visualization. Because of the new perspective that it adds, you have now the deepness, so you're able to display even more information that you could do than before. And of course, it's way closer to the reality if you include some environment with your visualization, like for network visualization, if you add a building or things like that, map, you will be able to figure out we're in this CD and we see the equipment at this place particularly, so it's intuitive for the user. And of course, it's something that can be really neat. It looks like we are in a sci-fi movie when you can just, from where you are, be able to see everything. But of course, when it's badly done, well, it won't be neat at all. You have a lot of problem with the 3D visualization because the deepness add more freedom for your scene. So you need to add some constraints because to navigate into a 3D world, it's really not simple, and we don't have the appropriate classic input device. Just with a mouse and a screen, it's not enough to be able to visualize a 3D scene, you need to add the shortcut with the keyboard, which make your things way more complex. And with just a 2D visualization, with only the mouse, you're able to do all the interaction that you need to do. But things can change because now we have virtual reality that's coming with HTC Vive, the Facebook Oculus Rift, or reality headset. So in the future, maybe you will be inside your scene and be able to view anything. So this is really a short pro and cons about 3D visualization. So what I think it's important to understand is to use it if you need to use it. It's not because it will be neat that it's a good reason to move from 2D to 3D. And of course, it's something that is still really R&D friendly. It's not something that you will see in production. So it's debatable if we need to use it or not. But there's some feel that 3D visualization will be really useful for multilayer. Probably the first thing that we'll think about when you talk about the multilayer is with the smart cities. So in the next slide, what I will do, I will just explain the approach that we took at Inocybe to be able to do smart city visualization and multilayer visualization to integrate easily with OpenDaylight. So a smart city, if you have seen other presentation about it, it's something very complex. You have a big infrastructure behind it. So what we will do for the sake of this presentation, we'll separate it in 3 different components. The first one will be a visualization framework or application. It can be web or native. It's really up to you. The 3 major things that this application, a framework needs to do is be able to show a map. It's kind of optional. You can just have a plane where everything will be put in there, but with a map it's kind of more intuitive. You see more where you are. You need to be able also to see building. Another just another cue for the user to understand more where it is. And you'll be able to see a device. By device, I mean physical and also virtual. So we have some tools to be able to do it with OpenDaylight. The second thing that you need to have, it's a web service for a physical device location. What this web service will need to do is give us the geographical coordinate of this device and also some metadata that you will need if you want to have information from OpenDaylight. And of course, the third thing that you need for that is OpenDaylight. OpenDaylight has just everything that you need. You just have to do the good calls to the RPC and we get everything. So we just go a bit further on how the visualization framework work. So for the map, there's 2 API disponible to do it, because what we want, it's really the same thing that you see with the Google Map or OpenStreetMap, but it's for a 3D plane. So there's 2 API, like I said. You have the image tile API and you have the vector tile API. The image tile API that I will talk will be the OpenStreetMap API, because I didn't really look at the Google one. But simply a tilemap API, it's a representation of all the map split into multiple tiles by the size of 256 by 256. And you have an API scheme, which is your API URL, the zoom, the X and Y position. The X and Y position are obtained from mathematical operation based on the zoom, because at the zoom level 0, you will have 4 images, which is each continent. And if you go further, it will be the number of tiles will be exponential. So it's an easy way to be able to pinpoint the right tile that you need. So with the specific position, you get the tile and based on how many tiles you display, and you just fill everything based on the point where you are fixing your center. The vector tile API is kind of similar, but it's in JSON file format. So instead of having a picture, you will have just a list of vector. And when you just connect those vectors together, we're able to do a shape. And the interesting part of the vector tile API, if you have one layer per component, when you use the image tile API, you have everything. So the boundary, the lake, the highway, the road, every information will be there. So you can have maybe too many information. So with the vector tile API, you can just fetch what you need, build the image yourself, and show it. Now for the building part, there's two ways to do it. If you just want to have a simple building for, say, a high zoom level, what you suggest to use is use the vector tile API, because we have the building information for the small 2D shape. So if we extrude it in the new axis, we're able to have a 3D shape building. So with that, we'll be able to have a 3D building. So I have a small example here of a GeoGesion file. So this one is just add a simple, I think it's a cube, maybe not, but it's a quadrilateral shape. So we have our shape, and we also have some properties, so we can include the metadata if you need it. The other way that we can build things can be with the 3D model, and that's probably what we will do for devices also. So for building devices, we look a little bit over the internet to see what's if there's something existing to be able to do it, and actually the KML file format is able to do it. KML stands for key markup languages. It's an XML-based standard that supports 3D model, and it's used by Google Earth to display geographical data. So we have an example here on the right of what this file will look like with a 3D model. So with the new tag model, we can set the location, the orientation, and the scale, and link a file to it, and also a resource file to it, which is the texture that the model will use. To include the model, you will use the KML file format, which is a zip archive. When it's root, you have your KML file, and you have your other file included in this archive. So basically, it's how we think we can do it. We can have this part included in OpenDaylight, but we think that would be a better idea to keep it outside OpenDaylight, because it will be easier to maintain. And it is also the reason why you will need it's the reason why you will need the geographical web services to be able to fetch those files. So the way that we'll do it, it will be the same way as the other, with the same URL scheme, but instead of being a JSON or image file, it will be a COMZ file. So if we look at the big picture of what it should look, you should have your application. You will fetch your image and GeoJSON information from the internet to be able to have your map and your building if you decide to use the simplest building API. And you can use also the web services for the device info to be able to get the model for your building or your devices. And you can include also some metadata with your in devices. So after, you can use OpenDaylight to be able to have the information. You can use after a call to OpenDaylight, and in this call, you'll include the ID of your devices to get all its property and how this network will work. So that's nearly about it that I wanted to share with you today. I would love to add a demo or some screenshot to you, because currently we are developing a visualization library, but it's still in the early stage of development, so we didn't have some visual yet. We're mostly focusing on the architecture to be able to have something modular and scalable. So you will heard more about this library shortly, and also we will planning to put it open source to be able to share with everyone and be able to improve it with a community. And so that's about it. All right, welcome everyone to this presentation about 3D visualization of multi-layer networking. I'm Maxime Millette Coulombe, software developer for Inocybe Technologies. So we're about 20 minutes over the schedule, so I will try to do it quickly, so we won't lose too much time for other presentations. I will start with understand and correlate the most possible content of our dataset, and we want to be able to show it in an easy way that everyone can be able to understand it. So if I can just show a little example, if you try to connect OpenDaylight to Mininet starters, it's kind of a question hard to answer, and sometimes some managing people can be afraid of doing this touch, because it can you need to have maybe a different expertise to be able to do it. So we'll just reduce a little bit this case, because 3D visualization is very a global scope. So for networking data visualization, we'll try to answer another question which we kind of simpler. It's why just do some data visualization. So one of the reasons, again, there's a lot of answer to this question, but in this particular scope of this presentation, we'll say that we use visualization because we want to quick questions. So why should we start? Why should we visualize in 3D? Because for the network visualization, it's rare that we see it something displayed in 3D. Sometimes, really, most of the time, is 2D, because 3D can be useless. So when we are talking to see if it's something that we need to do or not,